Hello folks, welcome to the part 3 of our building a SimpleDB in Golang, where we mainly use this book as a reference. But if you are new to the series, you can check out a short introduction video for more context and to see the other materials that I'm using. As I said, I'm using Golang to implement everything, but frankly, you can follow along in like any other language. And now in this video, we're going to talk about the log manager. Okay, a log manager is a component that essentially logs or writes log records to a so-called write-ahead log. Write-ahead log. This log is essentially used to roll back like failed transactions and also to perform a crash recovery. So basically, every write operation, like update or delete, will be first written to this log and then applied to data in memory. This is important because if you remember from our last video, the database engine will do its best to minimize disk access. All right. So basically that means that every data manipulation will actually happen in memory. And then at some certain point in time, all of those dirty pages will be flushed to the disk. But the problem here lies if before the dirty pages are flushed to the disk, the system can fail, right? The system can crash. And in that case, all of those updates will be lost. That is why we need something like a write-ahead log to first log all of those operations before applying them to memory. And write-ahead log is almost always durable. So in case of a crash recovery or restart or something like that, the system will read the write-ahead log and it can reapply all of those missing operations. And that way, we will not lose all of those requests. This notion of write-ahead logging or write-ahead log is like one of the fundamental design principles in databases, like generally. It is used for restoring backups. It is used for point-in-time recovery. And also in distributed databases, this log is essentially what is replicated to all of the other nodes in the cluster. Then those nodes will apply the changes from the log to their dataset, and that way will be in sync with the rest of the cluster. In different databases, you will find that this log has different names. So for example, in MySQL, it is called like binary log or bin log. In Postgres, it is actually called write-ahead log or WAL for short. In MongoDB, it is called op log or operation log and so on. But essentially, they are all the same thing. Now, in the context of our SimpleDB, the log manager basically only takes the data, writes it into this log file safely and durably, and also provides a mechanism to read all of those records in the reverse order. We will talk about it in a moment. But it doesn't care about the contents of those log records, okay? So the clients of log manager, so that is transaction manager and recovery manager, we will cover those, we will implement those in the upcoming videos. They actually know how to interpret all of those bytes, and they know what is actually being logged. The log manager doesn't care about it. He will just simply take the data, store it durably and safely, and call it a day. Also, what is worth mentioning is that write-ahead log is generally only append-only file, right? Append-only structure. So basically, what is written in the file will never change. So there is no like in-place updates or something like that. Now let's see how everything works. Okay, so the way that log manager works is basically like this. When you create it, it will first create a page of data in memory, like this. So let's say this is RAM, this is disk. Okay. Then it will check if there is a log file on the disk. If not, it will create a log file like this. Let's call it L, log file, and it will have only one block. Okay. The stuff that I'm talking about, pages and blocks, if you're not sure what I'm talking about, you can check out the second video or the first part when we talk about the log manager. Where we talk about the file manager, and there everything is explained. Okay. So like I mentioned, it will create a log file with a single block. Okay. When the log records arrive, so when the log manager logs actual data, it will log or write everything into this page in memory. So like this, log record 1, this is log record 0, this is This is log record 1, 2, 3, and so on. Okay. When the next log arrives, something like this, as we can see, it will not fit into this page of data. When that moment arrives, everything will be flushed to the disk. So this page will be flushed into this block of file, okay? Then the log manager will create a new block and also will create a new page, like this. We can, of course, reuse this page, like we can overwrite data over this existing data, okay? But for simplicity and ease of inspection and stuff like that, I simply create a new page, and this old page will be garbage collected. Okay, so like I mentioned, when this page is filled up, it will be flushed to disk, to this block. The log manager creates a new block, creates a new page, and the same process. It will log records into this page, like this. When everything gets, when the page gets filled up, again, it will be flashed to this block, and it will create a new block, and so on. You get the point. Also, like we will see in a moment, the log manager has a flush method, so you can do a flush whenever you want, right? So you don't have to wait like that the page gets filled and then you flush everything. Of course, depending on what is a transaction manager doing or a recovery manager, it can log stuff, call a flush method, flush everything, and then continue with its operations. Let's now check out the code for this. So we have a log file. Okay, so this is our log manager. This is the main struct. Like we see, it holds the log file itself. We need a file manager. We need this log page that we will log records into. We have the current block. The current block is basically this last block in the log file. Okay, and then we also have this latest LSN. LSN is log sequence number. So every log record that we log will have its log sequence number. It will basically like monotonically increase 1, 2, 3, 4, 5, and so on. We will talk about it in a second. And we have a couple of functions and methods here. The first one is the constructor. So this basically does what we explained earlier. Initially, we create a file block, and also we create a new page. New page, of course, is size of the new page. Size of the new page is the block size, all right? And then we check the log size, or the size of the file, or the size of the log file, okay. And like we mentioned, if the log size is 0, we will write to the first 4 bytes. In this case, we will write the block size. I will explain it in a second, but okay, let me show it like this. So when we create a page like this, and like this is slice of bytes, the first 4 bytes are reserved for the current offset that we have in the file, that we have in the page. Sorry. So the current offset is basically the beginning of the last record in the page. We'll see it a bit more in a moment. And initial offset is the block size. Basically, the page is empty. Okay. So if the log size is 0, we will write so the current offset at the 0th offset. So basically these first 4 bytes, like I mentioned, and so we write that data to the page, to our log page, and then we write this initial block to the file. When it comes to creating a file, the file will be actually created in this file size method, and it will work like this. Basically, we call this file, but this we'll call this method from file manager. Get file, what it does. So first we check if the file name is already opened. If not, this method will create it. So at this moment, our log file is created. Okay, go back. Okay, so like I mentioned, we will write this current block or first block to our log file. All right. And if the log size is greater than 0, that means we already have a log file. In this case, we set the block number as the log size -1. So basically, our file is comprised of blocks 0, 1, 2, 3, blah, blah, blah. Okay. And the log size is basically in this case, it is like this file size will actually return the number of blocks from the file. Okay. That is essentially log size in this case as well. And we just say log size -1 to get the number of the last block in the file. All right. And then we will read that block to our log page. And we will fill our struct like this. We have a file manager, we have a log file, we have a log page, and we have a current block, and we will return. So that is our constructor. Okay, so besides our constructor, we have these basic 3 methods. So this log method basically will take a record, a log record, and put it in the file, append it to our file. We have a flush method. It will basically flush the page that is in memory to disk. Essentially, it does that. And we have this iterator method that will actually return an iterator that allows us to go over log records in the reverse order. I will explain it in a bit more detail. But let's first check out this log method. Let's go back actually to see this a bit more clearly. Okay, so let's say we have a page like this. So the size of this page is 32, so 32 bytes. First thing that I want to mention, like I already said, the first 4 bytes, let's use a different color, the first 4 bytes is reserved for the offset, meaning the offset is a place where the last record starts, last written record starts. Initially, it will be the size of the page or the block size. And in this case, it will be like 32. Okay. So when the new record comes, let's say we want to log a record like size of 8. So we have a record of length 8. Okay. So we will store it from right to left. So let's say this is size 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. This is our record 1. Let's say record 1. Okay, like this. But we in the context of a record, we also use additional 4 bytes like this. Okay, to store the length of the record. So in this case, it is these 4 bytes, and we will store the number of 8. Basically, all the log records comprise of the data itself plus 4 bytes that hold the length of the record. We need this length when we will talk about the iterator. Okay. When we store this record 1, so we have 8 plus these 4 bytes, that is 12. We update the offset. So the offset will be 32 minus 12. Okay, so 8 bytes of data plus 4 bytes for the length of data. Okay, and so the new offset will be 20, right? So 32 minus 12. So the new offset is here. Okay. Record 2, let's say it is 10 bytes long. So from this new offset, like that is here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the data of R2. Okay. R2 data plus 1, 2, 3, 4. The length 10. All right. And the new offset is this current offset, that is 20 minus 10 plus 4, 14. 20 minus 14, it will be 6, right? So the new offset is 6. It is right here. And let's say now we want to write record 3. Let's say it also has length of 10. Now we will check if there is room. Basically, we take the offset that is 6, and if it is greater than the log record, basically it can fit. If this is smaller than the log record, basically that means it cannot fit. In that moment, the log manager takes this page, flushes it to the disk, okay, like we mentioned here, flush it to the disk, and create a new block and create a brand new page. So basically this page will be flushed to the disk, and the file manager, the log manager, we create a new page with the offset of 32, or the offset is like the initial offset is the page size or the block size. So that is basically how the log method works. Let's now check the code. Okay, here we are. So first we check, we want to like that only a single go routine logs. So first of all, we read first 4 bytes from the page. Okay, like this is the byte slice that we will put the current offset that is stored in the page. Okay, so the length of the byte slice is this int byte size. It is basically 4. Okay, then we interpret those bytes as the integer or unsigned integer 32 in this case, and this is our offset. Basically, like the command states, offset is the place where the last record starts. The last record that is stored starts. Like we mentioned here, this place, like this. So this is the start of the last record in this page. Okay. Then we see if there is place in the page. So basically buffer capacity, we take the offset minus the byte size, or minus these 4 bytes that will store the offset in the page. So we take this offset 6 minus these 4 bytes here that will store the offset. So in our case, 6 minus 4, 2. So the buffer capacity is 2. 2 is smaller than this R record of 10. Okay. So basically, we take the length of the record. This total length is a helper that will basically return the length of the data of the record plus these first 4 bytes that we store for all the records, like this one. So the total record is basically this 8 bytes plus these 4 bytes that will hold the length of the record. So when we go back here, we take this total length of the record. If it is greater than the buffer cap, basically that means it will not fit into the current page, then we will flush everything. We will call flush method to flush the page to the file. Then, like I mentioned, we create a new file, but we can use we create a new page, but we can use the exactly the same page. We can overwrite data with ease, but just for simplicity and to easier inspect everything, I just create a new page, and the old page will be garbage collected. And like I mentioned, we will create a new page. We will increase block number. Basically, that means we create a new block, additional block, and we write that block to the file, or we write this page to this block, okay? This essentially will, like we saw here, this essentially will create this new additional block on our log file. So we create a new block, and we set the new offset, okay? The new offset, or the initial offset, is the block size or the page size, like we mentioned. And we will write that offset to the page at the offset 0. So basically meaning these four bytes will hold this offset. Okay. And okay, so this happens if we don't have the capacity. We create a new block, we create a new page, and so on. But when we are done with that, or if that is not the case, we take the record position. This record position is the position of this new record. Okay, so what we actually take, we will take the offset minus the total length of the record. So basically here, the new position. So when we write this record 2, the new position will be this offset at this point, which was 20, minus the total length of this record 2. Basically, that is new offset, okay? 6 in our case. So the record position is offset minus total length. We get a page, and we write at this offset record position, we write bytes of the record. This bytes method is also a helper, and it will return the bytes of the entire record, meaning the first 4 bytes that hold the length of the data plus the data itself. Okay. So we will write this new record to the page, and like I mentioned, the new offset is this record position, and we will update the current position with this new value. So basically, we will take the page, we will write integer at position at offset 0, meaning we will write it to these first 4 bytes. Okay, like that, and then we will increase this log sequence number like this, and then we will return this log sequence number, and we will return nil for the error. And that is essentially how the log method works. And the third method that I mentioned in this is this iterator method. And let's now talk about how it works actually. And before that, like I mentioned, the flush method basically will write this log page to the current block in the file, and that's it. And also we will update this latest durable LSN. We will need it later, and return nil for the error and call it a day. Okay, so let's return to this iterator method. The iterator method, when you call it, it will first call this flush method. So we will flush everything, okay, that is in memory, and then we will iterate all over the log records, and we will return the new iterator. Let's check it out. So the iterator basically holds the file manager, we need it, the current block, the current position, and the page of data. Okay, the current block, like we see here, it is the current block, so basically the latest block in our log file. Okay, sorry, it is the latest block, and we will move backwards. We will see that in a moment. And the current position is basically like the offset. We could call it also the offset of where the position of the last record that should be read. All right, let's see it in a bit more detail. So the new iterator will essentially create a new page, and it will read data from this block that is passed to the iterator, that is actually the last block in the file. Okay, it will read it into the page, into this page of the iterator, and the current position will actually be the offset that is stored in the beginning of the page. So if you go back here, this current position is basically when we read this page, okay, the current position is the offset, actually, like I mentioned. So we will read that, we will get the current position from the page, and we will return the iterator with current block being the block ID, so essentially the last block in the file. Current position will be, like I mentioned, the offset, and the page will be this page that we created here. So let me first describe how the iteration works. So let's say we have something like this. So like I said, when we log records, we create a page that will actually be flushed to the disk, and we log from right to left. So we have like first log 1, 2, 3. Okay. Then this gets filled. We create a new block like this, and from right to left again. In this case, we have block 4. Then we have block 5. Then we have block 6. And like I mentioned, these first 4 bytes, of each block will hold the place of the beginning of the last written record. So this block will hold position of this record, and here this will hold the position for this one. So that is how we log record. So from right to left. When we iterate over the log records, we go in reverse order. So we start from the end of the file, from the last record, and we go all the way to the beginning. So the reversed operation happens. So when we iterate over the log files, over the log records, sorry, we will take the last block, so block 2, and then we will first read block 6, then we will read block 5, then we will read block 4, so 6, 5, 4. When the offset is equal to the page size, that means that we have read all of the log records from this block. Then the iterator will move to this block and continue the same process. We will first read block 3, okay? Then we will read block 2, then we will read block file. So the end result will be block 6, 5, 4, 3, 2, 1. So that is the algorithm. And let's check everything in the code. So like I mentioned, the new iterator will return the iterator, okay? This has next method. First of all, this API, I'm not a great fan of it. I think we can have a much nicer API, similar like we have like in Go when it comes to reading SQL records, something like that. This API is more like Java-like, and maybe that is the reason I don't quite like it, but maybe not. But for now, it is good. So this next method basically checks if the current position is smaller than block size, like I mentioned. So if this current position that is stored here is smaller than the block size, so this point, that basically means we still have potentially records to read. Okay. Or if the block number is greater than 0, that basically means that we have a next record. Okay, it will return true. And this next method does the next thing. Okay, so we first check if the current position is equal to block size. So what I mentioned earlier, when this current position that is stored here is equal to the block size, so basically it points to the end of the block, that means we have read all the records in the block, and we want to move to the previous one. So that is exact thing that we do. The current position, if it is equal to block size, we call current block number minus or -1. Okay, so it was block number 1 here, or second block, minus. Now the block is this one, the first block, and we take this previous block and read its data to our page. Okay, then we take this new data, new page. We read the offset in that page, so this part here, or these first 4 bytes, and the current position becomes that offset from the page. Okay. So when we are done, when we check this, or if we don't have to check this, we first take the length of the record. So let me see here, this length. So we first read this length. Sorry, we first read these 4 bytes to get the length of the log record. Okay, so that is this value here, length, and then we read the data from the page like this. We will take the current position plus these 4 bytes that store the length. So basically, let's say we are reading this record 2. Okay, we will take the current position. We will take the current position that is in this case 6. So this is this current position, and we add basically these 4 bytes that hold the length of the record. Okay, and then we will, from this point here, we will read the next 10 bytes like this. Okay, so these 10 bytes here. So we will read that data from the page, store it in this data variable, and then we will create a log record. Length will be its length. Data will be the data that we just read, and we now move the current position, and we do it in the reverse order that we done when we log record. So basically, we take the current position and we move it to the right by adding the total length of the record. So in our case, we move the current position like this. It was 6. Now we add to 6 the total length of this record, it is 14, okay? So the new current position will actually be 20. It will point to this log record, okay? And we return a record and call it a day. Next time you call this next method, we will actually, the current position will be 20 at this moment, at this point here, and we will read the next record, that is this one here. And that is basically it. Of course, for everything we have tests. I have simple tests to cover everything, more or less everything, and you can check those out. Out on your own. That is it, guys. It is a bit tricky. It can be a bit tricky, and I did my best to try to explain everything as simple as possible. I hope I did a decent job with it. I hope it was helpful to you. And yeah, in the next video, I believe we will implement Transaction Manager. Thank you for watching. If you want, you can help me out by maybe clicking the like button, or even maybe consider subscribing so you don't miss videos like this. Thank you very much. Hope it was useful to you, and we will see you in the next video. Bye-bye.